Today we'll explore how to find the value of sine inverse of 1/2 and understand what this means geometrically using the unit circle. Let's start by writing our problem. Find sine inverse of 1/2. Before we solve this, let's understand what sine inverse means. Sine inverse of a value gives us the angle whose sine equals that value. In other words, we're looking for the angle theta, where sine of theta equals 1/2. Let's visualize this using the unit circle. The unit circle has a radius of 1 and is centered at the origin. We'll add the x and y axes, and we're looking for the angle theta, where the y-coordinate, which represents sine theta, equals 1/2. To find this angle, let's draw a right triangle. The hypotenuse is 1 because we're on the unit circle. The opposite side, which represents sine theta, is 1/2, and the adjacent side can be found using the Pythagorean theorem. Using the Pythagorean theorem, we know that the square of the hypotenuse equals the sum of squares of the other two sides. 1 squared equals 1/2 squared plus x squared, where x is the adjacent side. Solving for x, we get that the adjacent side equals the square root of 3 over 2. Now, we can find theta using trigonometry. The tangent of theta equals opposite over adjacent, which is 1/2 divided by square root of 3 over 2. This simplifies to 1 over square root of 3. Therefore, theta equals tangent inverse of 1 over square root of 3, which is 30 degrees. Therefore, sine inverse of 1/2 equals 30 degrees. We can verify this. Sine of 30 degrees does indeed equal 1/2. This is one of the special angles on the unit circle that you should memorize. And that's how we find the value of sine inverse of 1/2 using the unit circle and right triangle trigonometry.